My name is Daniel Brandeo. I'm the marketing lead for the advanced metering business for Schneider Electric. I've been with the company, we're just talking about it, 18 years. I'm based in Victoria, BC, Canada. So the topic for today's presentation is software-defined metering. And this is the agenda that we're going to follow today. We'll start with a brief introduction where I'm going to talk a little bit about what is it that we do in advanced metering, explain a little bit about our products and the value that we bring to our customers. Then we'll move into digital substations. So I'm going to give a pretty high-level introduction on digital substations. We have other sessions this afternoon, right after this session here on digital substations. So if you're interested in that topic, please make sure you attend that session if you want to get a more in-depth perspective on the topic. And then I'll jump into the software-defined metering topic, advanced metering in digital substations, and we'll finish with a conclusion. Okay, so as I mentioned, we are part of the advanced metering team. The advanced metering team is part of the digital power line of business in Schneider Electric. So the digital power, what is the digital power mission for Schneider Electric? The digital power mission is to accelerate the digital transformation of power management. We want to lead the digital architecture across energy management to create a unique digital experience for customers and partners. So if you were paying attention to the presentation this morning, Manish's presentation this morning, he was talking about how we do digital for efficiency plus electric for decarbonization to reach sustainability, green and smart energy. So this is really the Schneider vision on electricity for the zero, and it's really, again, very much what we do at Digital Power. I like what he said this morning too, that digital helps us to visualize energy, and that's pretty much what we're doing in Digital Power. So we're digitizing electrical distribution, so we're making energy visible to our customers, and that's at the heart of the Digital Power mission in Schneider Electric. Now, within Digital Power, we have a few different what we call leagues or business units. I'm part of the Advanced Metering business unit. So basically, what we do in Advanced Metering, we solve two types of problems, primarily to our customers and to the users. The first one is we help our customers to prevent downtime and recover from outages faster and safely. Okay, so that's what we call power quality monitoring. So we're helping industrial sites, we're helping electrical utilities to make sure that energy is that the electricity is running at a high quality, and if there is any problems, if there is any power outages, that we can identify the problem and recover from that problem as fast as we can. So when we talk about power quality monitoring, we're talking basically about, we're looking at three main characteristics for the devices, so the power quality monitors or the power meters. Compliance, so high accuracy, and when we talk about accuracy, a lot of times people think about, kilowatt hours energy, but accuracy is really important for power quality as well. So that's really key for power quality monitors, accuracy and compliance to standards. The second pretty important characteristic is actually the ability to measure the different power quality events. And that comes coupled with the ability that the devices have to basically sample the voltage and current signals quite fast so that you can detect those power quality events that a lot of times they're quite fast. So you need to a fast sampling of the voltage and the current so that we can detect those power quality events. And the third characteristic is really the ability to store those power quality events. If we think of harmonics, for example, you have, a lot of times our customers are logging up to the 50th harmonic, voltage, current, minimum, maximum, average. So you need memory, you need to store that information, and you need to be able to display that information according to the international standards. So that's the first value that we provide with our power meters and advanced metering. The second one is we help our customers to perform safe and reliable energy transactions. And really here, I'm talking about big blocks of energy. So primarily electrical utilities, utility transactions, big customers directly connected to the grid. This is what we call revenue metering for our advanced metering business. So when we talk about revenue metering, there's a few characteristics as well. I'm going to name 3 again. First one is very similar to power quality monitoring, accuracy, and compliance to the standards. So that's quite important for power quality monitors or for revenue meters. The second one is reliability and long-term stability. Okay, so you want to, if you're using your power meter as your cash register, you want to make sure that the device is accurate and that it stays accurate for a long time. And then the third one is around the security and how you protect the information from that device. So a lot of our revenue meters, they have physical anti-tampering mechanisms, but also hardware or software firmware features that will make sure that whatever is stored into the meter's memory cannot be tampered with. Okay? The reason I'm saying this is that really from a software-defined power perspective, those are the applications that we're targeting in the team that I work with. Okay, so we're not targeting, operational metering, the kind of metering that you get from protection relays. For most of the times usually using SCADA systems. We're really talking about power quality monitoring and revenue metering, which again are more advanced types of power monitoring. In terms of our product lines, we divide which kind of customers are interested in this value proposition. So basically the customers that need to maintain uptime. So that on the demand side means customers such as data centers, hospitals, continuous process, industrial processes. Those are the customers that we target on the demand side. So if we look at the demand side, those are the offers that we offer to our customers. So PM8000, I9000, HDPM 6000. You might be familiar with some of these offers. I know some of you guys here are definitely familiar with those. The other key market segment that we target is the electrical utilities, as I said, both for power quality monitoring, but a lot for revenue metering. So those are quite big, important customers of ours. And on the supply side, we have basically the ION 7400 meter and the ION 8650, even though the ION 9000 is often used in the supply side as well. Okay. So again, just a recap of the first part of the presentation here. We're part of the digital powers. We're digitizing electrical distribution. We target 2 main applications: power quality monitoring, revenue metering. So my presentation around software-defined metering will focus on those 2 applications, and those are the products that we are responsible for. So now we'll get into the digital substation topic. Again, this is a pretty high-level introduction of the topic. There's going to be other presentations throughout the event that are going to give you more in-depth analysis of the topic. But I think this is helpful to our conversation here. So I'm looking here primarily at a bigger substation, transmission level, grid level substation, where you have your PT, CT, so we'll call those sensors. So you have your voltage sensors, your current sensors out in the switch yard, and then you have your IEDs, so your electronic devices, intelligent electronic devices in the control building. Okay, so those could be protection relays, those could be RTUs, those could be power meters. The connection between the PTs and CTs is done via, basically copper cabling, analog signals, and all the analog to digital conversion that is needed for the operation of the substation happens at the device level, not centralized. Each one of these devices will communicate usually using a different communication protocol. They will be from different vendors a lot of times, so, a bit of a mess. Now, the move that we're seeing is the move towards what we call digital substations. And this is really something, it's not a dream, this is really happening right now. And really the main difference here is this magic box. So this magic box that we call SAMU, so standalone merging unit or merging units, what they do is they do the conversion from the sensors, so the analog to digital conversion, and then they send those samples using the IS25 process bus protocol. This is usually done with fiber optics to the IDs. Okay, so basically what's happening here, you are uncoupling the analog to digital conversion from the device level, and you're centralizing at this merging unit. Okay, and we'll talk about the reasons why this is advantageous. And then finally, what we see the future looking like is the idea that we will have a virtualized substation. So in this case here, you still have your merging unit. That merging unit might be in the future, or even today, there's manufacturers working on that, integrated with your PT and your CTs, and then you get to digital signals. But instead of having all the different IDs or the separated individual IDs, now you have software-defined functions or software-defined devices, and those functions are running on a server. So you would have your protection functions, your metering functions, your control, all running on a centralized server. So at this point, you don't have your IEDs anymore. You have basically software running your substation. Okay, so this is how we see the digital substation topic progressing. As I said, I think we have quite a few customers already at this stage, and we have customers experimenting with the third stage, and so is Schneider. Now, why is that happening? So I think it should be clear from what we talked here already. But on the conventional in a conventional substation, a lot of copper wiring, large footprint, challenges with integration and interoperability. As I said, a lot of these devices are communicating using different communication protocols. So very a big mess, as I said before. Now, what the move into digital substation gives us is number one, and that's again, if we're thinking about a larger substation, the first topic is quite drastic. So the reduction in wiring complexity, both the wiring from the copper wiring from the sensors to the panels, but also the wiring inside the panels where you have your IEDs. What it also gives us is better integration and interoperability. Again, we are standardizing on IS61850 process bus, so all the devices are communicating and consuming those digital samples using the same protocol, basically. Improved reliability, so less dependency on human operation and safety. As I said, a lot of substations today are using Modbus protocol, so protocols that are not super cyber secure. Now, when we move into IS61850, it's a much more secure environment from that perspective of cybersecurity. And then enhanced data acquisition, since more IDs will be accessing those samples from the merging unit. Now, on the virtualized substation, we have even further resource optimization. So now, again, you don't have the IDs, you have one server, one computational resource. So that brings the cost effectiveness into the table, more cost effective to deploy. Instead of having all the different devices, you have one centralized server, increased flexibility and agility, and advanced analytics and monitoring. Really, I think from all the discussions that we saw today, the challenges to increase generation, to increase the capacity of powering data centers, That means that we need to build more and more infrastructure. We need to build more and more substations, and really this, move into digital and virtualize is going to make this way faster and way more repeatable and easier to deploy in the future. Okay, so that brings me to the end of the second part of the presentation. So now we'll talk a little bit about the challenges with advanced metering. And again, I'm talking about mainly focusing on those two key applications, power quality monitoring and revenue metering, which are the key applications that we target on advanced metering. Okay, so the situation that we see today is, the digital substation innovation has been primarily driven by protection and control. You can have a substation without a power meter. You cannot have a substation. It's not wise to have a substation without a protection relay, right? So it's only natural that the innovation started from that side of things. Now, what's happening is that our customers, so this is getting more and more popular. So a lot of electrical utilities, for example, the innovation is being driven by the protection and control groups, by the innovation teams in these electrical utilities. And now there's other stakeholders that also need to, have access to the information from the substations. They are getting a little bit lost. And some of those are the people that are responsible for revenue metering and power quality monitoring. So this is starting to surface more and more with the deployment of digital substations. Okay, we can do protection and control, but what about my power quality meter? What about my revenue meter? What do we do in that context? And those are the questions we're getting from our customers, and those are the questions that we're starting to answer. And again, it's a fairly new topic for our business, and a lot of what we're doing is exploration with our customers. So what are the specific challenges with advanced metering? I chose 4 different challenges here, but there's more than 4. So the first one is around calibration and traceability. So as I mentioned before, a key aspect or key characteristic of a power quality and a revenue meter is accuracy. That accuracy needs to be verified. Those meters need to be calibrated and verified often. So every 3 years, every 5 years, depending on where you are in the world. So now that you are separating the analog to digital conversion from the calculator, what needs to be calibrated? Do we need to calibrate the merging units? Do the merging units meet the same level of accuracy that we have today with the advanced meters? Do they meet that accuracy over time? That the long-term stability topic that I mentioned before. So those are open questions right now that we're working with our customers to understand, customers and regulators, to understand how we can solve those. The second topic is regulatory compliance, approvals and standard compliance. So metrology regulations and standards, they take a long time to evolve. It's not something that you talk with the regulator, tomorrow they're going to change it. It takes time, and they need a vision. So they need to understand the end goal so that the standards can be updated. So that's a big part of what we're doing, again, with our customers today. I was with a customer last week and one last month, and they're starting to have these discussions with the local regulators on what needs to be changed so that we can have, again, advanced metering functions in digital substations. So that's a big challenge. The third one is related to security. So as I mentioned at the beginning of the presentation, a lot of the advanced meters that we sell today, they have protections, both physical protections, anti-tampering mechanisms on the devices, but they also have that on the firmware as well, right? Like, so how does that work now? Do we need the same? Do we need to seal the merging unit? How do we protect the calculator? How do we make sure that what is leaving the merging unit is actually what's arriving at the IED? Again, open topic. And the fourth one is what can be shared. This is a classic topic for electrical utilities. Usually protection and metering are quite separate. The CTs are separated. You have one CT for protection, one for metering. What about now? Are we sharing the merging units? Who has the right to access that device? And who, more importantly, who can change configurations, and how is that going to be managed inside an electrical utility? And again, just remember, those meters are the cash register for the utilities a lot of times, so it's quite sensitive information. The other topic that is not here is related to, as I mentioned at the beginning, the high sampling rate that we need with our devices. That high sampling rate, when we're using the IC61850 process bus protocol, we might have problems with bandwidth. So it might just not be possible to do that using that protocol. So what do we do then? Do we evolve the protocol? Is there any other creative solution? So again, those are topics that we're looking at and we are trying to answer. So how we're doing this? So this is what we're doing in the advanced metering business. So we are focusing our efforts first at the application level. So remember, this application could be running on a server or on an ID. But one of the things that we're doing is separating or decoupling the application from the hardware. Okay, a lot of the protection relays, a lot of the power meters, the application is tightly coupled with the processor, with the FPGA. So we are decoupling that so that we can run a metering application on Windows, on Linux, independently of the hardware. The second topic is around standardization. So there's a new standard, it's a technical specification around the virtual meter working with sample value protocols. So we're quite active in that work group that IEC has. But again, that is dealing with the application side of things. A lot of people think, oh, this is just a calculator, so there's no, there's no error that can be added to the measurement chain at that level, but it turns out that it can. So depending on the way that you do your calculation, you can add more error than you already have coming from your merging unit. So that's a pretty interesting standard. It hasn't been published yet, but we're working with other manufacturers and industry leaders on that. On the merging unit side, so we're experimenting with the data exchanging using the sample value protocol. So again, this is a fairly new topic for us. We want to understand again if there's limitations in terms of bandwidth, what is the maximum sampling rate that we can send across the communication channel with sample value protocols. So we're just experimenting with that to understand the limits of the technology that is available today. And then finally, we are characterizing the merging units for using with advanced metering applications. So basically getting a bunch of different merging units from different manufacturers and testing and playing and see how they behave with our applications, with the applications that we target, power quality monitoring and revenue metering. So that brings me to the last slide, and I think I'm right on time. The conclusion. So digital substation is a topic that is here to stay. Again, I think the value to the customers is too tangible and is too good. So it is here to stay. It's definitely starting at the transmission level, higher voltages. We're seeing a lot of movement, medium voltage, and then eventually even low voltage. I think we're going to see progress towards that digital scenario. The integration of advanced metering applications, those two key applications that I mentioned, power quality monitoring, revenue metering, has its unique challenges. So it's different from protection and control. And some of them are not entirely well understood yet. So that's part of my job. It's part of my role is to work with customers and try to understand those topics. They're fairly new into the market space. And then Schneider Electric, we don't want to fight this, technological evolution. We are committed to find a path where we can have our advanced metering applications working on the digital substation environment. What we don't want to have is, a fully digital substation with one piece of equipment that is still using conventional cabling and PTs and CTs. So we're working on that. And then finally, I'm very interested in discussing the topic further. I have my email address there. And if there is any customers from utilities, I know we have some partners here that work with electrical utilities. We do have an event in Victoria, BC, Canada for electrical utilities where this is going to be one of the main topics. If you are a electrical utility or if you're working with electrical utility, interested to understand more, please contact me and we would be happy to have you guys in Victoria.